This is Sharma solution, class 12, chapter 9, continuity. Exercise is a 9.1. Discuss the continuity of fx at the indicated points. Now these points are -1 and 1, and function is also given, and it includes the modulus, that is the absolute value. Absolute value means if you have modulus of x, it will be positive x if x is greater than 0. It will be negative x if x is less than 0. So this you have to keep in mind. Let us check at -1 and 1. So I'll do one of it. Let us take, because we have to check at -1, left hand limit and right hand limit will follow. The point is x equals -1. So if you go a bit, behind, or you can say you step back, it will be -1 minus h. If you move forward or you step in front, it will be -1 plus h. This h is very small number. It is equivalent to 0, not 0, but it is equivalent to 0. So -1 minus h for left hand limit, -1 plus h in the right hand limit. So let us do it. So mod, in place of x, just replace it by -1 minus h, and there is -1 already, plus in place of x again -1 minus h, and +1 is already there. So let us do this. -1 minus 1 is -2, so -2 minus h it will be, and this will be 1, -1, you can cancel it out, minus h plus. Okay, and this you have to keep in mind. So negative h will be positive h when it comes out of the modulus sign. You can write this -2 minus h as -2 plus h, and inside this, when you have a modulus, the positive sign will come out. So it will be 2 plus h. So this is 2 plus h, that is 2 plus 2h you can write. But eventually when you apply the limit h tends to 0, this is going to be 0, so only 2 will come, right? The left hand limit of this discussion is 2. Now coming to the right hand limit. So wherever x is there, we'll put -1 plus h. So -1 plus h I am putting in place of x. Here also -1 plus h plus 1. Okay. So here we have -2 plus h plus 1 minus 1 you can cancel. It will be h. So plus h is already h. And you can apply limit here also, or you can, because we don't know what will happen when we take it outside. So -2 it will be h. I am applying limit here only. So h is 0 of course, and when -2 will come out of the modulus, it will be 2. So you see here, left hand limit and right hand limit are same. Okay. So now we have to do one more activity. What is that activity? We need to put this -1 in this function and check whether the value comes to 2 or not. So I am just placing -1 here, -1 minus 1 and -1 plus 1. And this gets, this 1 minus 1 is 0. So modulus of 0 is of course 0. Minus 1 is -2. So modulus of -2 is 2. Okay. So 2, 2, 2. Left hand limit, right hand limit, and the value of the function at -1, they all are 2. So you can safely say that it is continuous at x minus 1. Now I want you to do this x equals 1, and I hope you'll be able to do it. This is the same way you have to do. Prove that fx equals this is discontinuous at x equals 0. So x minus mod x divided by x at x equals 0. So when you go a bit, step back, I'm just saying step back because we are going to use h. So at x equal to 0, f0 is already given as 2. This is already given in the question. So you don't need to check for that. You just have to see left hand limit and right hand limit. What will be the limit? Or you can directly find out the limit. See, limit x tends to 0. What do you get? X minus mod x by x. But what do you get here? There will be some problem, because this mod x at x, you will put minus h plus h like that. So we will do what? We'll use that modulus fundamental here. So when we have a point which is just behind 0, it is 0 minus h. In front of 0, it is 0 plus h. So let us replace this mod x by 0 minus h in this case, because when we replace x which is lower than 0, it is negative x. Above 0, it is positive x. So x minus of minus x is x plus x divided by x. X, this is 0 of course. This is 2x by 2. X gets cancelled. So it is constant. So even if you apply limit, what will happen? Nothing will happen, because it is constant coming. The left hand limit is 2, right hand limit is 0. They are not equal. So you don't have to check for any other thing, because this is discontinuous at x equals 0. Next one is, see, both the functions are almost same for x greater than or equal to 0 and x less than 0. They are almost similar, but there is a negative sign also. For this, we have to check at x equals 0. So 2x square plus k when x is greater than or equal to 0. So when we go on the right hand side, it will 2x square plus k. When we go to the left hand side, it is going to be minus 2x square plus k. These are the two functions you have to use. What should be the value of k so that fx is continuous at x equals 0? So let us see what is k. Do we get value of k, or let us see. So left hand side and right hand side, RHL and LHL. So x is 0, you have to check. So use 0 minus h on the left hand side, 0 plus h on the right hand side. Now just put here 2 in place of x. 0 minus h, I am putting minus h. It is similar. Minus h whole square plus k. On here right hand side, I am putting h. So 2h square plus k. So this is negative 2 minus h square is of course h square plus k. Here you have 2h square plus k. Okay. Now apply the limit. Limit h tends to 0. Limit h tends to 0 here also. So when you apply a limit, you see both sides, it will be k only. K is equal to k. So left hand limit and right hand limit are equal. But what about k? So we'll check the value of the function at x equals 0 also. And this is the equality sign, the first one. 2x square plus k. So 2x square plus k. So x 0 I am putting 2 into 0 square plus k, which is k only. So this k is value of the function at f0 at 0. All these three are k. So first of all, it is continuous. But how to get the value of k? We don't know. So we just have to give the answer that k can be any real number. This is the biggest set we know. We are not going to any other set that is higher than real number. Real number is the set we just talk about. For what value of lambda is the function this? This is the function. It is continuous at x equals to 0, and we'll check for plus minus 1 also. So first of all, x equals to 0, let us see what do we get, because we are not going to get anything. X equal to 0, you have to use what? Lambda x square minus 2x. So let us see the left hand limit. Let us see the right hand limit. In left hand limit, we'll put x as 0 minus h. Right hand limit, we'll put x as 0 plus h. This is lambda x square, that is, I am putting minus h only. So here also you can put h only. So minus h whole square, and minus 2 into minus h. And on the right hand side, we'll do the left, right hand side, but left will complete. This is h square. H square minus is plus 2h. Now I'm just showing it to you, but we can see that h is already there in both the term, and lambda is outside. So even if you take h outside common, it will be h plus 2 inside. So whenever you put h tends to 0, the whole term is going to be 0, so you won't get any lambda. All will be 0, because lambda is in multiple with h, and whenever you multiply anything with 0, you'll get 0 only. So how about getting lambda? You won't get it. Okay. Let us see the right hand limit also, then you will realize. 4 h plus 1. So limit h tends to 0. Now when we apply the limit, this is 4 into 0, that is 1 only. So it will come as 1. Now 0 it is, 1 it is. So when we put x equal to 0 in this function, that is f0 I am finding, it is the f0 I am finding, because we need to check for all of these. Let LHL, RHL and also the value of the function at this. The lambda 0 square minus 2 into 0, that is again coming to 0. 0, 0, 1. So it is not continuous which we see here, but we cannot say anything right now. So we cannot get the value of lambda in case of x equal to 0. I hope you got the idea. You cannot get the value of lambda here at x equal to 0. Continuity, discontinuity, you can see that it is discontinuous. 0, 0, 1 it is coming. It has to match. Okay. Now let us come to x equals plus minus 1. So either I'll take plus or minus, because 1 I'll leave it for you. Plus 1 I am leaving it for you, because minus 1 whenever it is negative, it is somewhat more effort to be done. So I'll do minus 1. X minus 1 we have to check. See, what we have to see is, this is x equals, this situation is at 0, because the question is given as 0. But when we talk about x minus 1, we are actually talking about way beyond 0. That is on the left hand side of 0. That is, you can easily put, I am taking minus 1, right? X at minus 1. So left hand limit you will put minus 1 minus h. There is no modulus, so don't worry about that. Just put minus 1 minus h. On the right hand side you have to put minus 1 plus h. X equals minus 1 plus h. Okay. Now because x less than 0 is lambda into x square minus 2x. So lambda, in place of x write minus 1 minus h whole square minus 2 into minus 1 minus h. Right? Okay. So let us do this left hand side first. So minus 1 minus h, I am taking minus common, 1 plus h you can write, it is squared. So minus square is plus 1 plus h square. I am taking minus from here, so there is already negative 2, so it will be positive 2. Positive 2 into 1 plus h. So negative whole square is positive. So you have to do 1 plus h square. So a square plus b square plus 2ab. So 1 plus h square plus 2h. Minus minus will be plus, so 2 into 1 plus h. So 2 into 2 plus 2h. So 2 plus 1 is 3. 3 plus you have 4h plus h square. And you have a lambda also. Now let us apply the limit. Limit h tends to 0. So these 2 will be 0, it will be 3 lambda. We will get some value here, okay? Just see the right hand side. It is minus 1 plus h. So 4 into h minus 1 I am writing 1 plus 1. 4h minus 4 plus 1. The limit h tends to 0. This is going to be 0. 1 minus 4 is negative 3. This is going to be negative 3. Okay. So left hand limit should be equal to right hand limit. 3 lambda has to be equal to minus 3. So lambda will be equal to negative 1. That is the value you will get when x is equal to minus 1. I will encourage you to do it for plus 1 also by yourself. But one more thing is remaining. We have to check it for f minus 1. The value of the function at negative 1. What it will be? Lambda, because x less than equal to 0 we have to check. Lambda minus 1 whole square minus 2 into minus 1. Lambda minus 1 whole square is 1. Minus minus is plus, plus 2, so it is going to be 3 lambda. Okay, 3 lambda minus 3. When you equate it, what do you get? 3 lambda equals minus, the same case. Again, you will get minus 1 only. Lambda minus 1. But in case of x equal to 0, you don't have anything to check or equate it to lambda, because lambda itself was coming as 0. Right? So x equal to 1, you have to do by yourself. This question we will going to take in the next discussion. Till then, thank you so much. Take care of yourself.